When presented with different loan or investment options, we can apply the various techniques we just covered to calculate various things that we can use to guide our final decision. This chapter looks at various such scenarios and gives the thought process involved in making the final choice. For the first example, we'll look at a situation where you're comparing different loan options. A couple wants to buy a house worth 3 million rand and decides to take out a home loan to do so. They note the following three banks as possible options. First is Bank F, which offers a loan with an interest of 8% per annum compounded monthly and a repayment period of 30 years. The second is Bank G, which offers a loan with an interest rate of 8.5% per annum compounded monthly and a repayment period of 20 years. And the third is Bank H, which offers a loan with an interest rate of 10.5% per annum compounded monthly and a repayment period of 15 years. The couple can only afford a monthly payment between 20 and 30,000 and plan to start paying a month after the loan is granted. Which bank offers the best option for the couple? Okay, there's a lot of information here, so we'll assess one bank at a time. For such kind of comparisons, you should calculate the following for all the different options and compare them to each other to guide your decision. First, the value of the regular installment, which will usually be on a monthly basis. Second, the total amount you pay over the repayment period, meaning the sum of all the monthly payments. And lastly, how much interest you're paying on the loan. So let's start off with Bank F. So first write all the information that's been given. They told us that it's an interest rate of 8% per annum compounded monthly, which gives the rate as 1/150. Then the number of payments is 30 years times 12 payments per year, so 360. And the couple wants to take a loan of 3 million now and didn't make any initial deposit, so P is equal to 3 million. The first thing to calculate is the value of the regular monthly payment, using the present value formula rearranged for X. And I put a subscript of 1 for the X, just so we know it represents the payment for the first bank. Then just sub in the values, giving the regular payment as 22,012 Rand 94 cents. Next, we need to determine the total payment made, so multiply this regular payment by N, which is 360 for this bank, giving 7,924,657 Rand and 40 cents. Then you just calculate the total interest being paid over the 30 years by saying total payment minus 3 million, which gives the interest as 4,924,657 Rand and 40 cents. Notice that the interest being paid is actually more than the value of the actual loan, which was 3 million. So the interest you're paying is actually more than 1.5 times bigger than the actual loan, which is pretty crazy. Already, this loan isn't looking like such a great option, but we still need to do the same three calculations for the other banks to see which is better. Let's look at the next option, which was Bank G. You'd follow the exact same procedure for the other two banks, so there's no point in me explaining the whole process again. I'll just do the full working for all of them and scroll down through the working, highlighting any important values. For Bank G, the monthly payment is 26,034 Rand and 70 cents. Then the total payment is 6,248,327 Rand and 28 cents. And the total interest is 3,248,327 Rand and 28 cents. So the interest paid for Bank G is also more than the loan amount of 3 million, but it's not as bad as the previous bank, whose interest was around 4.9 million. Then the final bank was Bank H. For this bank, the monthly payment is 33,161 Rand and 97 cents. The total payment is 5,969,000 154 Rand and 19 cents. And the total interest is 2,969,154 Rand and 19 cents. This time, while still quite a lot, the total interest is less than the actual loan amount of 3 million Rand. We've now done the calculation for all the banks. Let's compile all these results in a single table. Notice that while Bank F has the lowest monthly payment, it has the highest total payment as well as interest. Then Bank H has the highest monthly payment, which is roughly 10,000 Rand more than that for Bank F. But when you look at the whole picture, it has the lowest total payment as well as lowest interest. Therefore, based on just this information in the table, Bank H would be the best option. However, a certain restriction was mentioned in the question, which is that the couple has a budget restriction between 20 and 30,000 rands. Therefore, Bank H isn't feasible since the monthly payment is more than 30,000. That leaves banks F and G as the only viable options. Of the two banks, Bank G has the lowest total payment as well as the lowest interest. Therefore, Bank G is the best option for the couple. From this, there's one conclusion to be made. Once budget restrictions have been considered, the best loan option will always be whichever one has the lowest interest. That's because while the monthly payment gives some idea of the situation, and so does the total payment, it's the total interest you pay that takes all these different factors into account, and therefore is the best indicator for assessing a loan. Now you've seen a lot of stuff related to loans and present values. Now for the final example under finance, let's go back to looking at investments and future values. Srijit wants to start saving money to purchase a new car in 10 years' time. He plans to invest some money at an investment firm which offers 4 different investment schemes as its options. The different schemes all have different interest rates and different monthly deposits. Which scheme represents the best investment for Srijit? Similarly to the situation for loans, we would calculate 3 different things for each case and compare them. These being, first, the total future value of all the payments over the specified period, then the total amount deposited over the period, and last, the total interest earned on the investment. Here's the future value equation again. Since all investments are happening on a monthly basis over a 10-year period, the number of payments would be the same for all 3. 10 years times 12 payments per year, giving n as 120. So starting up with scheme T, the interest rate is 13.2% per annum compounded monthly, which gives the value as 0.011, and the monthly payment is 450 Rand. So just sub these into the equation, giving the future value as 111,131 Rand and 13 cents. Then the total deposited would be monthly installment of 450 times n, which is 120, giving it as 54,000. And total interest earned would be total future value minus total deposited, meaning this minus this, which gives it as 57,131 Rand and 13 cents. Then you just repeat the calculation for the other 3 schemes. I'll write all the working now. You can pause and try it out and resume, and I'll scroll down slowly through all the working so you can compare. So here's all the working. So some interesting things happen over here. As the overall deposit increases, so does the future value, which makes sense, I guess, because if you deposit more money each month, then it makes sense that the future value will be higher. But notice that the total interest earned first increases from scheme T to U, then keeps decreasing. So based on just this table, scheme U would represent the best investment for Srijit because it would earn him the most interest. And if you look back at the question, there's no sort of restrictions imposed on the investment. Unlike the previous loan example, where the couple couldn't pay a monthly deposit of more than 30,000 Rand, which ruled out some of the options available. But in this case, there's no restrictions. Therefore, the scheme earning the most interest would be the best investment option. But when answering these investment or loan questions, always notice whether the question mentions any sort of restrictions, because these will definitely affect what the final answer should be. Examples of restrictions that could be placed in the case of an investment could be something like, they could say Srijit needs to accumulate 130,000 Rand to buy a particular car, in which case scheme W would be the best investment, as it's the only one that would leave him with enough money at the end to buy the car, even though it doesn't really earn him the most interest. So like this, there could be a bunch of different restrictions mentioned in the question, so you need to apply your mind a bit based on the particular situation. Now I'll summarize everything we've covered in this video. First, we looked at the various formulas related to finance that you should be familiar with from before. And before I describe the formulas, these are what all the terms in the formulas mean. A is the accumulated amount, P is the principal or original amount, N represents the time period in years, and I represents the interest or depreciation rate in decimals. So if you're given the rate as a percentage, you divide it by 100. That being said, the first of these formulas related to interest, where you have simple interest, which states that A equals to P times 1 plus N times I, and compound interest, which states that A equals to P times 1 plus I to the power of N. Then you've also seen the formulas related to depreciation, where you have simple depreciation, which states that A equals to P times 1 minus Ni, and compound interest, which states that A equals to P times 1 minus I to the power of N. And lastly, the formula for nominal and effective interest, which states that 1 plus effective interest is equal to, brackets open, 1 plus nominal interest over M, which stands for frequency of payments per year, close brackets, to the power of M. And it's very important to note, whenever using these formulas, always ensure that the time units for the interest rate are kept the same as the time units for the time period. Then moving on to the new topics covered, we look at period of investment, which isn't anything that new. It's just using the same formulas as before, but this time solving for N. And it's not really so tricky to do it for the simple interest and simple depreciation formulas, but for the compound interest and compound depreciation formulas, there is a bit of a new aspect, which is the usage of logarithms, since you need to make N, which is the exponent in these formulas, as a subject. And the final formula you get for the case of compound interest is N equals to log A over P over log 1 plus I. Then the compound depreciation formula would be exactly the same, except it would be 1 minus I. Then we look at annuities, which are a series of regular payments of a fixed amount of money over a certain period of time. These payments are subject to a rate of interest, and it's usually quite helpful to draw a timeline to keep track of the payments. Then we looked at two types of annuities. The first is future value annuities, where regular payments are made, each of which earns interest, with the ultimate goal of accumulating a certain amount of money by a certain point in time. It's usually related to investments. This is the formula for it, where F is the future value of the payments, X refers to the regular payment amount, I is the interest rate as before, and N refers to the number of payments. And then two important things to keep in mind when applying the formula to different questions is, if the question states there's an initial deposit, then you account for it by adding 1 to the value of N. And another thing is, don't ever round off values and then use these round off values for further calculations. You can round off the value just for stating the answer, but if at any point after that you need to use those values in any calculation, then you can't use the rounded off values. You have to use the exact values. And the best way to do that is by saving the value as a variable in your calculator. Then we looked at present value annuities, which are regular payments made over a specified time period to pay back borrowed money. It's usually related to loans. And the formula is present value equals to regular payment amount times brackets open 1 minus 1 plus I to the power of minus n close brackets over interest rate. And again, an important point related to initial deposits like there was for the future value annuities, and that is that if there's an initial deposit, then you should subtract that value from the total value of the loan, and from then on treat that resulting value as a present value. Then you just calculate the rest as per normal. And the last thing we looked at was how to assess different loan and investment options. So first, there's the loan options, where you follow a certain 3-step process, where you first calculate the value of the regular payment, which is usually a monthly payment. Then you calculate what's the total amount you'd pay over the entire repayment period to cover the loan. So usually that would be monthly installment times number of months, or if it's a yearly installment times number of years. And then lastly, the total interest being paid on the loan. So in the case of loans, this would be total amount you're paying, meaning the value from this part 2, and then subtract the actual value of the loan. And the result you get would be the total interest you're paying. Then when comparing different investment options, calculate the following 3. First, the total future value of all the payments over the specified period. Then the total amount you'd be depositing over the specified period. So meaning number of months times monthly deposit, or number of years times yearly deposit. And then finally you calculate the total interest you'd earn on the investment by saying total future value minus total amount deposited. And then finally, after considering different budget restrictions related to making the investment, the option which earns the highest interest is the best. And that's everything we covered.